Okay, welcome back, everybody, as we delve a bit deeper into the world of triangles. The topic today is congruent triangles. So we have some vocabulary and some examples to help you with this concept. First of all, let's start out with just the definition of a polygon. A polygon is a figure formed by line segments. So a polygon can have any number of sides, 3 or more. But if you just join a bunch of line segments together, they will form a polygon. In particular, we care about congruent polygons, so we need to discuss what that is. So 2 things about congruent polygons that we need to know. First of all, corresponding sides are congruent and corresponding angles are congruent. Well, what do we mean by corresponding sides and corresponding angles? Well, those would be the angles and sides which would fall on top of each other if you put one figure on top of the other. They would line up. Okay, so what you see here is a couple triangles. Triangle ABC and triangle DEF. And we're given that in the blue ink there that they are congruent. So when you name these triangles that are congruent, you absolutely have to make sure that your letters are in the correct order. So when I say the triangle ABC is congruent to triangle DEF, if you look at the angles that line up, that would be angle A with angle D. Also angle B with angle E. And also angle C with angle F. And so when you look at those letters, the letters that the angles that go together are mentioned first. The angles that go together are mentioned second there. And then the last pair of angles that are mentioned that go together are third. They're the third letter. So the angles that are corresponding are mentioned in the same position in the statement. So we can get 2 ways the following statements. We can say that angle A is congruent to angle D by looking at the drawings of the 2 triangles or by looking at the order of the letters. They come first. We can also say that angle B is congruent to angle E. They are both, you can look at the drawings for that, or they're both the middle letters in the statement. And you can say that angle C is congruent to angle F for the same reason that you could look at the diagram, or you could say that they're congruent because they are in the third positions when you're talking about the statement. So we can mark those off here. So we can say that angle A is congruent to angle D. So I'll use one arc for that. Angle B, I'll use a double arc. That is congruent to angle E, so I'll use a double arc for that. And angle C is congruent to angle F. I'll use a triple arc, so I'll use a triple arc to show that those angles are congruent. Okay, so you can also say the same thing for the segments. So notice that segment AB is congruent to segment DE, so we can make a mark on those, showing they're congruent. And notice also, again, at the statement that AB is the first 2 letters and DE is the second 2 letters, so they go together that way also. I'm also going to measure off, mark off side BC is congruent to side EF. I'll make that with 2 marks on each triangle. And also BC and EF, again, are in the same positions in the statement. And finally, AC is congruent to segment DF. I'll make that mark with 3 little tick marks there. And again, you can see that from the drawing or also from the statement that AC and DF are both the first and third letters in the statement. So that's what congruent triangles are about. Corresponding angles are congruent, corresponding sides are congruent. Okay, let's take this information and look at an example problem. So in the figure, we have 2 things to do. First of all, you see 3 triangles there, the big triangle, triangle EFG, and then 2 inside triangles. We are given that triangle EFH, that's the one on the left, is congruent to triangle GFH, that's the one on the right. So those 2 triangles are congruent, meaning that all their corresponding sides are congruent and all their corresponding angles are congruent. So our job is to find the value of x. So if we look at what we're trying to find here, we'll see that this angle, which is the right angle, corresponds to this angle in the other triangle. Okay, so that means that 6x minus 12 must be 90 degrees. Another way to look at that is to see that 6x minus 12 and that right angle there add up to a straight angle, so they're supplementary. In any case, if we're going to find that value of x, we're just going to have to set 6x minus 12 equal to 90. 6x minus 12 is equal to 90 because we know it is, because that's a linear pair there. And then so that'll give us 6x equals 102. And we'll go ahead and divide that and get x equals 17. X equals 17 for that. All right, so there is how you find angle x. Now, same drawing, different question. Let me remove these yellow marks here so we don't get too confused by that. Okay, same drawing. I'll move back up there in a minute. We're going to find the measure of angle GFH. The measure of angle GFH. So I'll highlight that. Angle GFH. So we're looking for this angle right here. We can use any new geometry as well as any old geometry to figure this out. Okay, so one way we could do this is know that angle E is congruent to angle G, right? Because if you look at the letters, E and G are corresponding angles. They're congruent there. So we can write in here, that angle is 21.6 degrees also. Now we can use one of our old theorems to get this angle right here, because that's one of the acute angles of a right triangle. And we had a theorem that said that the acute angles of a right triangle are complementary. So just take 90 minus that 21.6. 90 minus 21.6 should give you 68.4. So that's that missing angle that they were looking for. Okay, so you can use new theorems, old theorems, whatever you know in your bag of theorems to solve the problem. And there you have it, 68.4 degrees for that missing angle. Okay, we have one more problem to do in this video, and this one's actually going to be a proof. I know that's what you were looking forward to. So here's a diagram. All proofs have to have a diagram and have to have a given information and then what you're trying to prove. I'm not going to do a two-column proof. I'm just going to walk you through this, and we'll understand it that way. So looking at the diagram, we're given that angle P and angle M are right angles. So I've got that marked off already. Angle P and angle M are right angles. We're also given that point R is the midpoint of segment PM. And we're also given that segment PQ is congruent to segment MN. So I marked both those off with a single tick mark. And likewise, we know that segment QR is congruent to segment NR. That's given, so I marked those off with a double tick mark. Now we're trying to prove those two triangles congruent. So we're trying to prove triangle PQR, the one on the left, is congruent to triangle MNR. Okay. So the way we're going to prove them congruent is we're going to show that the three pairs of corresponding sides are congruent and the three pairs of corresponding angles are congruent. Well, if you look at those two triangles, they already have two pairs of corresponding sides congruent. But let's go back up and look at what's given there. They said that point R is a midpoint of segment PM. So we can now, with that information, mark these two segments off. By definition of midpoint. If we were doing a two-column proof, we'd say definition of midpoint, those two segments are congruent by definition of midpoint. So now we have three sides of one triangle congruent to three sides of the other triangle. Well, that's good. We're done with the sides. Now let's prove that the three angles of one triangle are congruent to the three angles of another triangle. Well, we've got the two right angles. That's one pair. Now look at this. You got vertical angles right here. We have a theorem for that. Vertical angles are congruent. That's one of our oldest theorems. Don't forget it. You're going to use it again. So now we have two angles of one triangle congruent to two angles of another triangle. So now we have another relevant theorem called the third angles theorem. And that theorem says this. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So now we can mark off angle Q congruent to angle N by the third angles theorem. So now we have, if you look at the diagram, three pairs of corresponding sides congruent, three pairs of corresponding angles are congruent. That means the two triangles are congruent. Okay, that's it, but let me wrap up a little bit where we're talking about congruent triangles. First of all, we talked about polygons are just figures made by formed by line segments. So a polygon again is a figure formed by line segments. We said that congruent polygons have to have congruent corresponding angles and congruent corresponding sides. And we said also that the way that that statement is written, you have to make sure that corresponding vertices are in the correct order. That tells you the angles that are congruent and the sides that are congruent. And then we did a couple examples using all that information. So that's all you need to know. So on this particular assignment today, it's we're going to have 2 days of this. I guess I considered that important enough to do 2 days. And so we'll have a version 1 and version 2 of that. Okay, so there we go. And look at the posted assignments, and let's get some practice. Okay, take care.